Sometimes I can genuinely not believe how many takes it takes me to make a tutorial. Like, I've just been blabbering the same sentence over and over again, being like, no, it's wrong, and I just, like, restart it. There has to be something genuinely wrong with me. But today, I'm here to spread the Lord's word about 2D metaballs yet again, so watch the previous tutorial if you haven't. I'm gonna cram 2D metaballs so far down your throat, you're gonna be begging for air, okay? But this one is going to be 2D metaballs, but this time with a twist, because there's going to be way more nodes. Last time there were 7, this time there's more. This animation that you're seeing here is completely procedural. I can change like any parameter here, and it's always going to be loopable because of the math I put in. And additionally, you're going to see, contrary to the metaballs from yesterday, and this is something you can't easily do with 3D metaballs, so here's an actual advantage. We're doing kind of like the outline of the metaballs instead of doing something like greater than, and we're actually going to have control over the thickness of this and all that. So again, if you haven't seen the previous tutorial, I'm not going to warn you again. You watch it, okay? You're not going to understand this. This is going to be a step up, but other than that, it's been 30 seconds. I'll say it. Let's fucking go. You're not supposed to swear in the first 30 seconds if you didn't know. Okay, new Blender project, new day, new life, new opportunities. Here's what we're gonna do. I'm gonna set up the scene just the same as yesterday. So again, watch that tutorial. I'm done saying it in 3, 2, 1. Yeah, we're done. And the idea is I want to have a square, as you saw, and 2 circles passing through it using sine functions and all this. Either way, we already know how to set up our metaball distance functions. First thing we need to do is I'm going to set up the square one. So we have our object coordinates. This outputs the vector, or I guess the vector at every shading point on this plane. So this is 0, 0, 0. This is some positive x, positive y. Yeah, you get the idea. Okay. What I'm going to do is I'm going to make the square function. I think I already showed you how to make this one. You separate by x, y, z, since a square has an x component and a y component. And in fact, it's symmetric on both of those. So what I'm going to do, math node, set that one to absolute value. This makes it reflect, right? Because all the negative values are then flipped to positive values. So it goes 1.5, 0.51, right? Instead of having -1. I'm also going to do the same thing with the y-axis, so now we have both of these, and then to make kind of like the distance function between these we talked about, you take it, you put a maximum, and that's like the essence of it. Why does it work? I don't know. Why does, anything work? I mean, like, how do hot balloons work? Well, I mean, this one's simpler. The reason this one works is if you think about a square, the coordinates of it, or I guess the perimeter of it, is exactly described by picking the larger of the x or y components, where the corners of it is where x is equal to y, right? So the maximum is kind of like irrelevant there. But otherwise you'd get a circle if you were to be like, I want to keep a constant distance away. No, we're keeping the larger of the two. Either way, we have this basic function. If we do a greater than, we now can control a square. But again, the reason we're not doing this greater than is we want to have this gradient control, which makes the smooth min work, okay? Second thing we want to do is we are going to add in a circle. I think we're actually going to add in 2 of these. And by thing, I don't know why I say I think. I know we're going to do that. I'm going to take object coordinates, hook them up in here, set this up to distance. And again, the reason we do distance is this is the exact function that gives us the 3-dimensional vector-based distance between all these shading points and some origin that we're talking about. So you can think of this as the center of the circle, or if you're big brain, center of the sphere. Okay, so for the rest of this, I'm just gonna set up more of these, and I'll just go on a bit of a rant. So I'm thinking about drinking a gallon of water every day. Now I've read that at my weight that is excessive, so maybe I will not be doing that. But I definitely want to drink more water throughout the day. Right? I have a theory that it actually helps with your mood and stuff like this. So to my side, I wish I could show you, but I can't. I have today I'm doing 75% of a gallon, right? But maybe if I read more on it and they say I'm not going to die from low salt content, I'll consider it. What have I done? I've made 2 circles. Each one of these is independent from the other. So you can see, oh, there's one circle, and oh, there's another one. And we're kind of combining all these distance functions, right? Smooth minimum. We said this is the way to combine metaballs. Let's go over it just one more time. So I've connected the square gradient and the circle gradient, and right now if we were to throw this through a greater than or something, right, just kind of like our final filter, so we can actually see what's going on, you can see these objects are separate from each other. There's no fusing. But remember, the idea of smooth minimum is instead of just saying take the smallest of these, like minimum, we can say when it gets close to being close to each other, right? So again, we have this scenario right here where we have one function. I swear I'll stop explaining in a second. And another minimum kind of just takes this step here, right? It just takes the smaller of the two, so we don't care about this. Smooth minimum will say when we're getting close to that transition point to add a bit of smoothing. And that smoothing is going to be dependent on our smoothing parameter, right? I'm going to add a bit of this, and you can see those things are starting to fuse together. There's no like white wall in between these now. And now if we look at the greater than, you can see that they are fusing together. And the idea is we're going to have two of these. So 2 smooth minimums. And I guess it would be sensible. I mean, even though we can control them separately, I'm going to have one value to control their like smoothing amount, okay? So it's going to be the same number is the idea. So let's start off with something like 0.2. And we want to filter this. This is just our visible filter through a greater than. This is kind of like the threshold for what does and doesn't make the cut. Okay. Let's move these a bit out of the way so I can see what's going on here. Yes, okay. So I think this is like pretty good. If anything, I want to make everything smaller, so that's what the greater than does. But I want to exclusively make the square bigger. How do we do that? Well, we can't do it with the greater than. We got to control the part of the chain, the part of the node chain that takes care of the square. I feel like this has been a confusing tutorial, am I right? Either way, I mean, hopefully you've done the prerequisites. I mean, there should be no new ideas here. Just kind of like look over it again and again and again until your eyes roll into the back of your head and you wish you were comatose. Okay, cool. We got the square, we got the circles, and more importantly, they fuse together. And we can play around with that smoothing amount later. At this point, what I want to do is start the animation, and then I'll talk about how to do the outline and all that. So for one of these balls, I want them moving left and right, kind of periodically, actually exactly periodically. We're going to be using a sine function. For the other, I want the same thing, but this one should be moving on the y-axis. And you can see I'm trying to move only the y parameter or only the x parameter. So why not add in a combine x, y, z so we can actually control these mathematically, okay? So combine x, y, z is basically the same thing, but now we have 3 inputs instead of 1 vector input, okay? For this, what we are going to do is I'm going to show you, it's going to be a bit complicated. You're going to wish, oh, why don't you just type in like a driver with like a sign and a frame and all this? By the way, that's not a valid driver. Why don't you do that? Well, I want to have complete procedural control, and I want to be able to change stuff later. So first of all, I'm opening up the timeline. Why? Not just because I like it, but there's a reason. You're going to see that our project in this case is 250 frames. We can change it. We can have it be 125, 300, whatever. But the important thing is I want you to remember this number, okay? The idea is I'm going to add in a sine function that controls the x coordinate of this. So boom. We're going to do sine. Again, the reason we're doing a sine function is it oscillates between -1 and 1, which is exactly what we want. We want the x location to do that. I'm going to do a sine function. For the value, I'm going to type in hash frame. If you don't know what this does, it creates a driver that takes the frame number. So if we're on frame 1, it's 1, 2, 3, 4, 5, 6. I'm just going down the timeline, right? I'm going to attach this here. And you're going to see the issue in a second. I'm going to take it, and I'm just going to divide it by something just to make it a bit slower. And you can see it now animates. It takes the frame number and divides it by 10, so it goes 10 times as slow as it should, right? And the reason we do this is if this number is too small, it's kind of like way too fast, right? But you can see we're doing this thing. However, the issue is when we go to like just about the end of this, although I think coincidentally I picked a good number for this. But either way, you can see when it gets to the end of this, I believe it should not be seamless. Yeah, you can see right now it's on the left side and then immediately goes to the right side instead of having a couple frames of transition, as you can see. The point is it's not loopable. It's almost loopable, coincidentally, but if I change the number a bit, it might like no longer be close to loopable. Yeah, you can see now it goes from here to here, right? So the transition point's real bad, so you can see that, okay? We need some way to mathematically keep this nice so it's loopable, but I also want control. So here's what I'm thinking. We already know this is 250 frames. I'm going to take the hash frame, the driver, and I'm going to divide it by 250. Well, what does this do? Well, at every frame, frame 1, frame 2, frame 3, what we're actually outputting is 1 over 250, 2 over 350, 3 over 250, 4 over 250, etc. And if you think about what that means, it means we're basically going from roughly 0 all the way up to 1, right? Because we end up with 250 divided by 250. So what I've made is a slider that goes pretty much, not exactly, but almost exactly from 0 to 1 as we go across our timeline, okay? What I'm then going to do is I'm going to take this, I'm going to multiply it I'm going to multiply it if I can find it by 2 pi. This is just so it's periodic with the sine function. If you remember from a trigonometry class, sine has a period of 2 pi. So if you go 0, 2 pi, 4 pi, it's always going to be at the same number. But this should ensure that now if we go to the last frame, which I guess it's like perfectly in the middle, and the first frame, you can see it progresses only by a frame like we expect. But the nicer thing about this is now that we've made this nice expression, we can just multiply this by like an integer multiple. So, and it does have to be an integer multiple. So what I'm going to do is I'm going to put this in here, and I'm going to set it to some integer number. So not anything with a decimal, right? So I'm just going to set it to 3. And you're going to notice that it's ping-ponging. It's going to do 3 full oscillations. That's what this number describes. And then at the very end, you can see it's seamless, is the idea. The only reason why it's seamless, and we can actually change this number and it will continue to be seamless, is the idea. The reason that it is seamless is, again, because we are taking this like ratio over here that goes from 0 to 1 over time, and then we made it periodic, okay? Other thing I want to do, this is just stylistic. I'm going to throw multiplication after this sign, and you're noticing that I feel like it's going way too far back and forth. So I'm just going to multiply it by 0.5, which not only makes it go less distance, but additionally makes it feel a bit slower because it has to cover less distance. So of course the speed's going to be slower. So maybe 0.6 or something, okay? Cool. So now we have kind of like the basic, oh, I guess I did not save. That is a bad idea. Let's call it something relevant. I'm thinking Patreon, available on Patreon. It's true. Patreon link in the description. What the fuck was I talking about? I don't even know. We have this procedural thing, and the idea is now that we want to have the second circle, we only need to do a tiny modification to this chain to make it work. So for this other distance function that right now is kind of like off somewhere, right? We want to control this one as well. Same idea, right? We're going to combine x, y, z. Boop. And for this one, you just attach it not to the x-axis but the y-axis, which will let that load. And you can see now it's doing the exact same thing, and the metaball stuff interacts, you know, naturally with the smooth minimum, okay? Again, what's happening here before the greater than is we have these distance functions that we're basically just changing the center point of, right? And then we're calculating these smooth minimums and the greater than, okay? That's the idea. But for this y thing, so at this point I just want to add some visual interest. For this y thing, you're noticing that they're perfectly in sync. I want them to be exactly like half a cycle out of sync. I think that's going to add a bit of something. So to do that, what I'm going to do is I'm going to make its own little chain right here so that we don't have to have the same thing on both x and y for these two different metaballs. For this one, I'm going to weave in the exact same thing. So you're thinking, oh, CG matter, default cube. Have you lost your mind? Well, you're just using nodes for no reason. No, there is a reason. What I want to do is I want to add a bit of a phase or an offset. And if you remember from trigonometry, and don't beat yourself up, like don't like, you don't need to literally beat yourself into a pulp if you don't remember this, right? But if you add, I think it is pi or pi over 2. We can experiment. I think pi literally flips it. So you can see literally flips it because it's half a period. Because we said, remember, and this is where the 2 pi came from. We know that's a full period. So half of 2 pi, which is pi is 1. So you can see it flips it. Let me show that again. It flips it, but you can still see, even though they're like half a cycle out of sync, it's not really what we want. So I guess what we want is a quarter of a cycle out of sync. So pi over 2. So now whenever this is at its like highest amplitude, this should be near 0. So let's check that out. Yeah, now you can see they're out of sync. Okay, cool. So that's the basic part of the animation. It looks like a lot of nodes, but when you pack it all together, it's not that much, right? We have our texture coordinates. We have our square function. I then just scaled it, and then we're just smooth miniming with our two circle functions that are just being controlled by sine stuff to change the location, right? It's nothing crazy. But now I just want to talk about how did I get the outline thing? That's kind of an interesting question. That's very hard to do with 3D metaballs, right? We can't really look at the shell of them. Well, remember, what we're really calculating here is these smooth minimum like function things, right? There's no reason we need to do this greater than, right? These are all gradients. So the idea is, instead of that, why don't we use like something interesting? Like you could use modulo, and you can see it gives the same basic animation, but like more interesting. It actually distorts these rings and stuff like that. That's something to consider. But I didn't end up using this one. I used something a bit more boring. I used the compare node, and what the compare node does, you can almost kind of see it right now, assuming YouTube compression didn't ruin it. What it does is it takes our input, right, in this case the smooth minimum, compares it to some number, so we're taking this and comparing it to 0.111, and we're saying make the output white if it's within some threshold of this. So let's say like 0.04, make it white if it's within some radius or some distance of 0.111. What this ends up looking like is this is kind of the thickness of our line, and the nice thing about this is no matter like what the animation's doing and the metaballs and the fusing, this thickness should be constant throughout in some sense, which is something that's kind of hard to achieve otherwise. So that's kind of cool. Beyond that, we don't only have control of the thickness, but also kind of like the size of this metaball thing. Let me hold down Shift instead. And the fusing still works. It's kind of like a weird, I don't know how I would describe this slider, but you can get very different results very quickly out of this one, okay? So I'm going to take this, I'm going to invert it, is the idea. And again, if you were to do this like modulo idea, which I'm only now considering, I just want to mention this. Something interesting you could do is a greater than. You got to set it to a small number, and now you have the same thing, but like more complicated. But let's go back to what I was talking about. I'm going to invert the compare. The reason I invert it is because I think like black on white looks better, but you could pick your poison, is what the teens say nowadays. The compare node does the thing, but last thing I guess I want to talk about is, and let me just do a bit of a modification. Again, this is all procedural, so I can just change the size of the square. I want it to make it a bit smaller. We can also change the cycle speed, also the fusing constant. Remember, we have the smooth minimum fusing constant, so this is like a super blobby thing. Well, what's the point? I want to make it a bit more visually interesting, so I just want to add in a bit of rotation and a bit of like wobble scaling. So let me show you how to do that. Well, with the rotation, notice that this entire node network, whenever we're using texture coordinates, it comes from here. More specifically, it comes from here, which means if we do a modification here, that will propagate throughout the entire node network. So that's the beauty of this. So if I was literally to take like vector math and set it to like addition or whatever, you can see I can literally just move over the, whoops, I went too big there. I can literally just move over the simulation and nothing changes, right? Because it's being applied everywhere. So the idea is, what node do I want to add to rotate? Well, obviously vector rotate. Boom, vector rotate. For the angle, is this the right angle? I guess so. Usually I switch to Euler, so I guess we need 360. For the rotation, we can either hand animate it, or we could just use the nodes. Remember, we have this expression that goes from 0 to 1, because we're dividing by 250. I'm going to take this, and then I'm going to multiply. I'm going to multiply by, I think, 360, since it uses degrees. So the idea is it goes from 0 to 1 throughout the timeline, which when we multiply by 360, it goes from 0 to 360 degrees, which makes it loop. So let's see what that looks like. Nope, it's definitely in, I guess that's weird. When you drag it, is it in degrees? That is a weird bug. Either way, I guess that means we multiply by 2 pi instead, which means we don't need an extra node. So it's using radians. I don't know if that's intentional behavior. That was weird. But now, again, if we go to the last frame, you're going to see not only are the circles in the correct position, but the rotation just kind of continues. So it's seamless, okay? And just like the previous scenario, if you multiply by an integer multiple, so something like 2, it will still be seamless, because now it just does 2 rotations. But if you do something like 1.5, I believe that should break. Yes. So integer multiples, I guess 2 is fine. And for the wobbling, just like this we did here, we could do the vector, math scaling to, scale the texture coordinate system. Or something that's a bit more interesting, and this is what we'll go with, we can change... is it this one? Yeah, this one, because not only does it kind of look like scaling, but it does some more interesting interactions that I think are interesting. So just like the previous one, we can kind of like reuse some of our work from before. So I'm just going to use the sine function. We can plug it in here. So this is going to give us some natural wobble. Of course, the issue here is it goes from 0 to 1, or sorry, negative 1 to 1, I believe, because it's a sine function. Whereas like the value it's supposed to take on is something like close to 0.1. So quick correction, you take the map range, you connect the map range, we go from negative 1 to 1 to, again, it was like 0.1 something, so let's go from like 0.1 to like 0.15. In other words, what this map range does is it takes our input, which is the sine function, negative 1 to 1, that interval, and it sends it to something that's more in the range of what we care about. So let's see what that looks like. Okay, that's a bit weak. Let's divide this by 2 just so there's a bit more variation, and now you can see there's some more interesting interactions. And I don't know if it's an optical illusion or the math carries out or something, but I feel like when this is smaller, the circles are like speeding up to reach their destination. I don't know if that's mathematically true, but it does look cool. And again, you could change this at any time. You can make it have more variation, less variation. And also, cool thing, you can change the interpolation of this. So smoother step will give us the same thing, but now it's going to be much more like sharp movement. Or you could do stepped linear, which will look horrible. It will kind of like, quantize those steps, but that's almost an interesting thing. I think I'm going to stick with like smooth step or something like that. But yeah, that's the essence of it. Again, literally at any point, you could change any of these parameters to get different looking results. And this node group, well, what should we call it? I'm going to call it something good. This node group is going to be available on Patreon. Speaking of Patreon, we've arrived at the end of the tutorial. So as always, I promote. That's what I do. That's why I'm here. I'm kidding, but I'm not kidding. But I am kidding. On the right, you can see a list of 760 some now. Very loyal, very attractive patrons. I'll say it. They live longer. They have healthier nail growth. I don't know. Patreon exists. There's a link in the description. Why would you want it? Well, one, you get blend files, obviously, like this one. I'm going to package this up so you can use it. But additionally, any other blend file I've ever uploaded, which is in the realm of hundreds now, you can get with just a 1-month subscription. Additionally, exclusive tutorials that you do not get access to anywhere else, not on the CG Matter Default Cube channel. They're going to be there. I'm thinking about doing procedural 3D metaballs, so that might be a place to check it out once I make it. Additionally, Discord access, early access to tutorials. I'm like a week ahead on tutorials at this point. It's crazy. Get them a couple days early. Why not? And other than that, that's the essence of it. Like, you're not gonna. I know I said you would, but you're not gonna get more attractive by joining the Patreon. You're gonna get the things I described. There's a link in the description. If you care, you'll click it. If you don't care, you won't click it, and that's just about it. So, anyways, I hope you learned a thing about 2D metaballs, because like if you didn't, like, were you blindfolded, dude?